Hey Algebra 1s, I hope you're all doing okay and staying safe. Here's a review of what we talked about last time when we were together. You should have these notes already filled in with your packet. I'm counting on you having those packets that I copied and handed out to you on our last week together. A quick review of some definitions of what we're talking about in algebra. This unit is going to be, what is a polynomial? And anytime you have terms separated by a plus or a minus sign, that's what's going to give you what we call a polynomial. Standard form of a polynomial is going to represent when we have the highest degree first, and then on down in descending order. So an example of a polynomial that's in standard form would be if I had 3x squared plus 2x minus 7. So here we see our plus and our minus signs. And here's my highest degree. This is to the first degree. And then, of course, our constant has no degree of x. Okay. So our leading coefficient is the value in front of the first term. So in this case, it's going to be our 3. Our 3 is going to be our leading coefficient. Remember, coefficient answers the question, how many? So how many x squareds do I have? Or I have 3 of them. Okay, my degree is going to be the highest exponent. And in this case, our degree of this example is going to be quadratic. It is squared. And our constant term is going to be our value with no variable. Now, what I want you to also realize is that if I have here, for example, I have a negative 7, we could say that that's x to the 0 power. We know that x to the 0 power is worth 1. So this would have a value of 1. That's why this negative 7 here has no x's. 2 x's here, 1 x here, and of course, no x's there. All right, so we have a couple different words that is important for us to all understand and know, and that is when it comes to these polynomials, we need to know what they're called and we need to know what they're about. So we're going to go ahead and we're going to say these ones here are going to be constants because they have a degree of 0. That's like having x to the 0 power, remember, is going to be equal to anything to 0 power is 1. When we look at this story here, when we look at these x's, these are both x's to the first power. So we're going to call these x's linear because my degree is going to be 1. When I look at here, I have my x squareds. Our fancy word for those are quadratic. And our degree on those is going to be 2. They are squared. Our next value, our next term is going to be if we have x cubes as our highest value, we're going to call that cubic, and that is going to be our third degree. If I have a fourth degree, That is where I have any x to the fourths as my highest value. Then I'm going to call that quartic. I want you to think about 4 quarters in a dollar. So if your highest degree matches one of these, then we describe that polynomial using that classification. The second way to classify this is by the number of terms. So when I look at how many terms are in each of these, now remember, a term is going to be anything that is separated by a plus or a minus sign in a polynomial. So when I look at how many terms are happening in this first example, here's just one term. Even though there are 2 factors, this is still one term. Even though there are 18 and then 4 x's, that's still just one term. And these are all just one terms. If they're one terms, we call them monomials. If they have 2 terms, you can see that they are separated by that plus and minus sign. And we can go ahead through it if we wanted to. We can talk about each of these things that separates our terms, and that helps us count how many are in each of these. If I have 2 terms, I'm going to call that a binomial. If I have 1, 2, 3 terms, I'm going to call that a trinomial. And this is what's interesting. If I have 4 or more terms, I'm not going to continue using those fancy words. I'm going to use a generic term that describes all of these and polynomial. So the prefix poly just means more than one. So my fancy terms are for 1, 2, and 3 terms. When I hit 4 or more, I just use that generic term. So here's what's interesting. We have this conversation now where I can take a look at these 2 examples of polynomials, decide whether the function is a polynomial function. If it is, write the function standard form, and then state its degree, classification, and leading coefficient. All right. When I look at standard form, my first thing I want to check out is what is the highest degree, because the rule is the highest degree comes first. So what I'm going to do here is say, okay, this function of x is going to be equal to negative 3x to the 4th. That sign goes with the leading coefficient. My 1/2 x squareds are positive. My negative 7 is my constant term, and he goes last. So I went from 1, 2, 3 terms to 1, 2, 3 terms, but I switched the order around using the commutative property. I'm allowed to switch things around with any addition conversation. So if I wanted to, I could think about how these are adding the opposites, and that's what allows me to use the commutative property and change it around. It is a 4th degree, which means that it is a quartic polynomial. When I talk about the number of terms, because I have 1, 2, 3 terms, I'm going to call it a trinomial. And that leading coefficient of negative 3 tells me a lot about it. Now, when you get to Algebra 2, all of these things have an impact on your answers, the graph, and what the graph looks like. So that's why we're learning this. It's important to start these conversations now, so when we need it in higher level maths, we know what we're talking about. All right, standard form here, f of x is equal to my highest degree comes first, my constant comes last. Because this is x to the 3rd power, I know this is a cubic. 2 terms makes it a binomial. And this leading coefficient that I know is there, that I can't see, is 1. All right. Let's check out the back. All right, so you have 2 more examples. I'm going to let you try these, and I want you to fill them in, and then you can go ahead and check back with your answers. All right, so we started off with a trick question here. This -1, we can't have a negative exponent. That changes our functions around, and they become a rational function instead of a polynomial. So guess what? We're not going to classify this as a polynomial. All right, when we talk about this next one, we have a quadratic. We put this power out first. It's fine to keep the decimal. I would prefer you use 1/2 as a fraction, but the decimal's there, so it's fine. That's a trinomial and a leading coefficient of 1. Okay, here's why we care. We want to try to keep things in mathematics as simple as we can, so we understand this idea of combining like terms. So remember, our like terms are going to be values that have the same variable to the same power. So the easiest way is to go ahead and combine like terms, and we can add them vertically, or we can just combine the terms that are alike. So if you look at this first example here, I'm going to go ahead and put this x cubed underneath here, because those are going to be like terms that are going to be a part of what I add. My negative 10x squared lines up. I don't have an x, so I leave that blank. And here's my plus 8. So when I go ahead and I combine like terms, I add vertically, where I have 3x cubes, and I understand this is a coefficient of 1. So 3 of these plus 1 more of these makes 4x cubes. 2x squared minus 10. When I add 2 and negative 10, I get negative 8x squared. We don't have any x's here, so we'll just bring down that, because that's negative 1 plus 0 is still negative 1. Negative 7 and positive 8 makes positive 1. So what I was able to do was rewrite each of these terms underneath the ones that were alike, and then I was able to stack them and add them, which makes it easy for me to see that this is a simpler expression than those two separate pieces. All right, the second method is just to scan and look for like terms. So I see a cube here, and I don't see any other cubes, so I know that 9x cubed is my only cubed function. Here I have negative 2x's, but here I have 5x squared. So those 5x squared are going to come next in my standard form. So sometimes when I do this, I'll cross off as I go. Negative 2x's, positive 12x's is going to be positive 10x's. 1 and negative 4 is minus 3. So we're good to go. When we talk about subtracting polynomials, we need to make sure that we keep track of our signs. So when subtracting, our first step is we want to make sure that we distribute the negative. Then I can choose a method above and combine like terms of the polynomials. All right, so here's what I mean about that. This negative sign means I'm taking this whole thing away. So I'm going to be subtracting 2x cubes. I'm going to be subtracting 6x squared. I'm going to be subtracting negative x's. I'm going to be subtracting 1. Notice this negative sign changed the sign of every single one of these values. So now that I have these with the correct sign, I can go ahead and stack them with their like terms. This is 2x cubes that are negative. This is negative 6x squared. This is a positive 1x and a minus 1. So when I go ahead and I combine these like terms, I'm adding, giving me 6x cubes, negative 9x squared, negative 2 and positive 1x is negative 1x, and then plus 8. When I check out this next one, I'm going to be subtracting x, subtracting negative 4, and subtracting negative 3x cubed. If you can see what we have here, this negative goes to each term, and that shows me how the sign of each changes. Now, if I wanted to stack these under here, I could, or I can just use the method of where I'm going to combine like terms. I only see 1x cubed, one term that has cubed x's. I have 3 of them. And I've gone ahead and I've included him. Now I'm going to check out and look for my next, and I see I have 2x squared. They're positive. So I combined him. Positive 3 and negative 1 x's is going to give me positive 2 x's, positive 3 and negative 1. And then, of course, I have my 4 constants. So when you're combining, adding and subtracting polynomials, you're looking for the like terms. All right, good job.